Welcome back to Spring Into Math 8. I'm Mr. Burns, and today we're talking about our content review or chapter review for this chapter. Let's dive right in. The first topic of this chapter was unit rate. You may ask yourself, what is a unit rate? Well, a unit rate is a comparison of two measurements, one of which always has to have a value of 1. Let's take a look at this example together. John rode his bike 36 miles in 2 hours' time. We're asking ourselves, what is his unit rate? Or how fast or how far did John ride in 1 hour? Let's take a look at how we dissect this problem. Number 1. First, we're going to write this rate as a fraction. The term that needs to be reduced to 1 is the hours in order for us to get the distance he rode per hour. So I set it up as follows. 36 over 2, or miles over hours. Step 2. We're going to ask that we simplify the problem and the fraction we've created by both dividing the denominator and the numerator by a number that goes into both of those evenly. In this case, that number is 2. So I'm going to divide 36 over 2, both the numerator and the denominator, by that number 2. Now when I do that, 36 divided by 2 is 18, and 2 divided by 2 leaves us with 1. So we can see here that John rides his bike at 18 miles per hour. Or we could say it in this way. John rides, for every 1 hour John rides, he rides the distance of 18 miles. Topic 2 from this chapter, unit rate and slope. Let's talk a little bit about what the slope formula is. In this lesson, we talked about slope, and just remember that when we graph it, it's a line, and we look at the rise over the run. For example, every 3 seconds, 4 cubic feet of water pass over a dam. We're asking that we draw a graph of the situation to find out the unit rate and see if this has a proportional relationship or not. You should know that a proportional relationship when graphed has 2 characteristics. The first characteristic is that the graph is a straight line, and the second characteristic is that line must pass through the origin, which is located at the coordinates 0, 0. So you can actually make sets of coordinates out of the information in this data table. The first coordinate would be 3, 4. The next one would be 6, 8, and so on down the line. Now if you plot those, you're going to get a graph that looks a little bit like this. We can see here clearly on our graph that we have time on the bottom and the amount of cubic feet on the y-axis on the left. So we're looking for the slope of our line. Okay, so we're going to use what's called rise over run. We're looking for where that line crosses in 2 corners exactly. Not off, but we have to be very precise about this so we get the correct slope. Now here, we're counting up from the purple line, which is rise, and we counted up 8 spots. Our run, which is going over to the right-hand side, is in blue. Okay? So this will have a slope of 8 over 6. All right, last but not least for this chapter review, graphing proportional relationships. We're going to take a look at this problem. Weston and Jaden both like to go on long bike rides. Weston's data is going to be plotted on a graph, and Jaden's data is going to be plotted in the form of an equation. And we're going to determine which person or which gentleman here rides at a faster pace. But we're also going to check to see if they ride at a proportional rate, which would mean the same pace. Let's take a look. On our graph here, on the x-axis, we have hours of our trip, and on the y-axis, miles traveled. So we can see here, if we read the graph, that 5 hours of riding time gives us 10 miles, 10 hours on our trip gives us 20 miles, and so on. Let's take that data off of the graph and take a little bit of a deeper look. Based on the graph, we can see that Weston rides 10 miles in 5 hours. Now we're going to set that up as a fraction so we can find the unit rate. 10 over 5 reduces down to 2 over 1. Or we can say that he rides at 2 miles per hour, or the distance of 2 miles in the 1 hour that he rides. Let's pull another set of data off this graph, another coordinate here, to make sure that we have a proportional relationship. Here we pulled off the coordinate 30, 15. Now to reduce 30 over 15 to the smallest, simplest form, we're going to divide both of those numbers by 2. And so on until we get down to 2 over 1. So again, we see here that he is still riding at that constant pace of 2 miles per each hour. So his constant pace, or we can say with confidence now that he rides at 2 miles per hour. Really, he's riding at a very slow pace. Hold on to that information while we take a look at his friend Jaden's pace. Now it's not in the form of a graph, but we have an equation here. Y equals 20x. X stands for the number of hours, and Y stands for the number of miles that he rides. So let's plug in some numbers for Jaden's ride to see what we have here. We're going to use the numbers 5 and 15. So we're going to plug them into our equation here, and I'm going to get y equals 20 times 5, which is 100 miles. Then I'm going to plug in y equals 20, and for the x value, I'm going to put in 15. And 20 times 15 gives me 300 miles. So we're going to take those information and put it into some fractions. The first one is 100 over 20. And if I reduce that to its smallest, simplest form, that comes out to 20 over 1, or 20 miles per hour. Now let's make sure that he's riding at a constant pace by plugging in another fraction. In this case, 300 over 15. And we're going to reduce that down, and lo and behold, it actually also equals 20 over 1, or 20 miles per hour. So we can say that Jaden rides at a constant pace of 20 miles per hour. Now, we can also say that Jaden rides 10 times faster than his friend Weston, because 20 miles per hour compared to 2 miles per hour, we can see that 2 times 10 makes 20. All right? Thanks so much for paying attention today. Catch you next time in the next chapter. Good luck.